All right, so now you've got 3 graphs up there. What's my alternative? What am I looking at here?
Well, this set of charts is, at the top is the total intensity, luminescence intensity. The middle is the difference, or is the left and the right, counts of the left and the right circular polarization. And the bottom is the computed G lume, which is what typically one looks at.
Okay,
Now, in this case, we see in the repeating scans, particularly here, 612, the great big peak,
right?
is changing. And that occurred because I've added about 1/4 of the sample is now water,
Okay,
which made the DMSO solution of europium stuff not go from clear to cloudy. But
right?
I had to, when I added only 10% or so water, it didn't seem to make any difference.
All right,
I had to go to a good 20% water before I see it. And the change, well, notice the G lume is hardly changing.
what about the LPL and the NPL? Does that change?
No,
Yeah, so let's pull up those
All
graphs and
right,
look
so
at those.
let's pause and say, what about let's include in the picture here the non-polarized luminescence and the circularly polarized luminescence.
And what about the linear?
Well, I can put the linear in too.
Okay.
Having done that, the data will be recomputed, and here it is. And I
Right.
can resume data collection, and I see that, in fact, with this heavy dose of water, there is a change in the G lume to some extent, or at least, I should say, in the circular CPL.
The
Yeah,
CPL.
Now, the LPL is very low in this sample in any event, and we'd have to do more signal averaging to have that come out, but it's very small. Notice these numbers are down only to 100 or so counts,
Oh, wow.
whereas here we've got 1,000 counts, and here we've got 1,000,000 counts, so it's a very small contribution.
Right,
However, finally, well, it's interesting, not too surprising to me, to what I've seen, is that changes in the peak here aren't as dramatic, where here, the big tall peak, the presence of water has made quite a dramatic change.
there you go. Okay,
And one can do these as a function of time. I'll probably we'll prepare a fresh solution. In this case, the sample is a total of about 0.9 milliliters in a 4 by 4 millimeter square quartz cuvette. So it's and I've demonstrated to myself a couple hours ago that if I raise the cuvette a centimeter or so in the cuvette holder, I get very similar, or get the same data, and that would allow me to put only a 0.5 milliliter in the cuvette.
oh, wow,
Very economical sample, which is rather nice.
no doubt.
And
Well, thank you.